We're going to look at some alternate methods for messy trinomials. Hopefully you can hear the air quotes there. These are trinomials with the form ax squared plus bx plus c. So a, b, and c are all some form of integer, usually. We've already kind of gone over on Moodle how to factor by guessing. It's not my favorite method. I'm not going to go for that. What I am going to do is show you a couple of other options that work pretty cleanly. So first thing you always want to do when you do have something in front of the x squared, check for a greatest common factor. Do it all the time. So you may, if you're really lucky, actually end up factoring out whatever number is in front of the x squared, in which case that's ideal. You don't have to worry about it. If nothing else, it makes it a little bit easier for the other forms of factoring. I'm actually going to go for factoring by grouping first. This is also known as decomposition. The way we set this up is we look at the numbers in front of our a and in front of our c. So if we look at any trinomial, whatever number is in front of the x squared is our a, whatever number is in front of the x is our b, whatever number is a constant at the end by itself is our c. These could be positive numbers or negative numbers. In our case, with the first example, that's 2 and negative 12. So we multiply those, and we call that finding AC. It's just the product of those two numbers. For 2 and negative 12, that would be negative 24. Okay, this is the product we're going to be considering. Two numbers that will multiply to 24, and then we'll figure out the positive or negative afterwards, and that have a difference of 5. So let's start listing numbers that multiply to 24. I'm going to list all of them, but you'll find as you do this that you don't really need to. So for example, 1 and 24 are so far apart, I know they're not going to have a difference of 5, or a sum of 5. 2 and 12, not quite, but getting closer. 3 and 8, that sounds like a very promising way to get a 5. And just to be complete, we could also do 4 and 6. So just by looking at these offhand and thinking about sum and difference, either adding the numbers or subtracting the numbers, I can see that I should go with 3 and 8. Now one of these will be positive and one of them will be negative to have a product of negative 24. Okay, so again, it could be negative 3 and positive 8, or it could be positive 3 and negative 8. And usually by looking at that, we can figure out which one we need. Go back up here, we have a plus 5x. So we need to have a sum of positive 5. Negative 3 and positive 8 will give us that. So this is actually our option for our x values, negative 3 and 8. What we do to factor by grouping is we actually split up our middle term into two pieces. 2x squared. Instead of 5x, I'm now going to write it using these two numbers that I just found. Minus 3x plus 8x minus 12. I'm just going to put a little separator in there so we don't run out of space. Now, we're not actually changing our trinomial because negative 3x plus 8x does combine to 5x. But what we're doing is breaking it into two manageable parts. Now I have 4 terms. I guess I can just call it a polynomial. What I'm going to do is factor by grouping. So look at just the first 2 terms and ask myself, is there anything I can factor out of those 2 terms? Then I'm going to look at the last 2 terms and ask myself, is there anything I can factor out of those 2 terms? I'm going to give myself a little more space to work, so I'm going to keep this polynomial but kind of take away all those other numbers. There we go. So 2x squared minus 3x doesn't really look like it has a lot to factor out, but if nothing else, we can factor out an x in front there. So out of just my first 2 terms that I'm looking at, I'm going to factor out an x, which leaves me with 2x minus 3. And now I'm going to do something similar with my next 2 terms. I've got 8x minus 12. Can't really factor out an x this time, but I have 8 and negative 12. I could factor out a 4 from that. And I'm going to look at that 8x to kind of guide me on whether that should be positive or negative. It's positive, so I'm just going to factor out positive 4. And in brackets, what's left behind is 2x minus 3. Okay, again, I'm not changing the value of the expression. If you multiply out using distributive property, you'll still have 2x squared minus 3x plus 8x minus 12, but I'm factoring the first two parts and the last two parts, and the hint that I'm on the right track is notice I have 2x minus 3 and also 2x minus 3. That actually gives me my next piece I can factor out. So I'm not done factoring yet. I can now factor out, and I'm going to keep it in brackets, 2x minus 3. And what's left when I factor that out? Take a look at what I left behind. First it was being multiplied by an x, then it was being multiplied by a 4. And again, notice that's being added on, so I need to keep that plus sign as well. So my second binomial is actually x plus 4. And this gives me a fully factored version. Again, I could check my binomials and make sure there's nothing else I can factor out. But it looks like that's all I can do. To test this, I can multiply it back out, 2x minus 3, and multiply it by x plus 4, use distributive property to get all four terms and combine like terms. You should be able to get back to 2x squared plus 5x minus 12. Let's do the same thing on the second example, but go just a little bit faster. So again, I start off with a and c. For 3x squared minus 7x minus 20, my AC value is going to be 3 times negative 20, which is negative 60. So I want two numbers that multiply to negative 60 and have a sum or difference of negative 7. Just by looking at that question, instinctively I know if they're multiplying to negative 60, I'm going to have a positive number and a negative number. When I combine them, they combine by adding or subtracting to negative 7. It sounds like that's going to be a subtraction. So I'm looking for two numbers that are at least 7 apart. Now again, you can list every single combination, or you can be a little bit smart about it. So for example, I know 6 times 10 could possibly give me 60, and then one would be positive and one would be negative. Those only have a difference of 4, so maybe I want a bigger difference. 5 times 12, that also multiplies to 60, and 5 and 12 are 7 apart. I know I need one positive and one negative, and when I have a sum of them, it's going to sum to negative 7, which sounds like I want positive 5 and negative 12. So that gives me my two numbers that have a sum of negative 7 and a product of negative 60. What I'm going to do is rewrite my trinomial, 3x squared. Instead of minus 7x, I will replace it with plus 5x, minus 12x, minus 20. So it still has the same value, but I'm taking that middle term and I'm splitting it into two parts. That's where the decomposition comes in. And then I'm going to factor by grouping. So look at just the first two terms and see what I can factor out. Then look at just the last two terms and see what I can factor out. With my first two terms, I have 3x squared plus 5x. Really, the only thing I can factor out is an x, and that leaves me with 3x plus 5. With my second two terms, I have negative 12x and negative 20, and both of those are negative numbers. But even if just the first one was negative, that would already be a good indicator that whatever I can factor out can be negative. Now I have 12 and 20. It sounds like the biggest number I can factor out of those is 4. So I would have minus 4, which leaves me with positive 3x plus 5. Okay, again, check that really carefully. Make sure if you multiply it out again, negative 4 times 3x plus 5, it should be equal to negative 12x minus 20. And again, we see we have the same kind of binomial in brackets, 3x plus 5, 3x plus 5. That's a really good indicator that we're on the right track. So out of both of our parts of our polynomial, we can factor out a 3x plus 5. And what does that leave behind when we factor that out? It leaves behind an x and a minus 4, and again, don't forget that sign. So our fully factored form is 3x plus 5 times x minus 4, and again, we could multiply that out to kind of check, do we have the right answer? It may seem a little longer, but as you get used to doing this a little more quickly, it's actually a pretty fast method. Just as a reminder, I call this decomposition because we break it into the two parts, but it is a form of factoring by grouping.